In this module, we will cover the command pattern, also called the action or transaction pattern. It allows us to encapsulate requests as objects. I'm Kevin, and I'll guide you through it. We'll start by describing the pattern using a real-life example. As real-life example, we will use UI interaction, clicking a button to add an employee to a list. After that, we will map that example to the structural pattern. We will also implement our real-life example in a demo, and we will look into a variation which will allow us to support undo by using a command manager. We'll continue with learning about use cases for this pattern consequences, and we'll end the module by looking into related patterns. Let's dive in. The command pattern is a behavioral pattern from the Gang of 4 library of design patterns. Behavioral patterns define ways to communicate between classes or objects, letting you concentrate on the way objects are interconnected. And the command pattern is a very nice illustration of that. Its intent is to encapsulate a request as an object, thereby letting you parameterize clients with different requests, queue or log requests, and support undoable operations. It thus turns the request into a standalone object. And once we've got an object, we've got something to work with and/or pass around. Let's clarify this a bit. A very typical example of a command is clicking a button in a user interface. For example, to open a file, add a product to a shopping cart, add a new employee to a list, and so on. In a naive implementation, we could just write the code for that in the button click event handler. But that comes with some potential issues. You might want to separate concerns by not having the code for handling the request, the button click in our example, at the same location as the button itself. You might want to be able to reuse the actual code that needs to be executed. And maybe your application architecture doesn't even technically allow you to implement the code for the button click in the same place as where the button resides. For example, when you've separated out the buttons or menu in a separate project that doesn't know about the receiver of the actual request. And that is where the command pattern comes in. It allows you to decouple the requester of an action from the receiver. This pattern is very common in mobile or rich UI development, where you would typically use the model view model pattern combined with the command pattern for transferring UI interactions to your view model. At that level, the actual command would be implemented. A command would be bound to some UI XAML code, or if that's not possible, could manually be executed via the button click. You can see examples of that on screen now. Don't worry if that code doesn't look familiar. It's just here for illustration purposes for those of you who've got some experience with the MVVM pattern and/or XAML development. Let's learn how we can create these commands. Let's say we're building an employee manager application. In it, we want to add an employee to a list of employees a certain manager manages when a user clicks a button. The object that invokes the command could be a button on the user interface to which a command is bound or on which a command property is set. Adding that employee to that list, that's executing the command. So we could have an interface, iCommand, containing one method, execute, to execute the command. The interface could also be implemented as an abstract class, as we know by now. A good name for the command, in our case, would be add employee to manager list. This class implements the iCommand interface and executes the action, actually adding the employee to a manager's employee list. For that, the command needs something. It needs to know who the employee is. It also needs to know who the manager is. So that's additional state that the command must hold. Once our command is being executed, something needs to happen. The employee needs to effectively be added to the manager's list. We could use a repository for that, on which we can call a method to add the employee. And that brings us to the last part, the client application, which creates the commands. In our case, it would pass the repository through to the command when it creates the command, typically via the command constructor. And with that, we've got our pattern. Let's map this to the pattern structure. We'll start with the object that invokes the command. This is the invoker, and it's responsible for asking the command to carry out the request. It maps to the menu button from our example. iCommand, our command interface, maps to command. It declares an interface for executing an operation. The implementation of that interface then is the concrete command. That maps to our add employee to manager list command. It defines a binding between the receiver and the action. It implements execute, and it does that by invoking the corresponding operations on the receiver. And that brings us to that receiver. The receiver is an object that knows how to perform the operations associated with carrying out our request. In our case, that's our repository, but any class may serve as a receiver. And lastly, we've got the client. The client creates the concrete command and sets its receiver. And that's the pattern structure. Let's implement this in a demo.